Nampak bukan lip.
Boleh lah. Boleh apa tu?
Ya bodoh lip.
Style dulu. Style dulu. Dah macam. Macam style dia. Jadi kalau kau pandang macam tapi dia kena meja.
Okay, ready ya. Actually, all the modules every time for people absent, you really need to say it's okay, right?
It's okay. It's their loss. Attendance is their loss. Attendance doesn't mean that big.
I think even though sometimes they say a lot of agent lecture thing is cheap, it's few hundred per day compared to if you go pay consultant training, right? But again, it's back to the society, to technology and all this. So yeah, just hope you guys enjoy the course. Yeah. Always try my best, but my best is always up and down, right? That's what we call now, right? And we're working live. You can't really do that every single day, right? So this is for the last one for advanced technology. There are about 22 slides here. So we talked about, we cover a lot on surface wellhead. We did the basic stuff, conventional. Then we expand a little bit to compact wellhead. That's how a compact wellhead. Let me start record.
Yeah.
So we know the benefit, the pros and cons between the conventional and compact wellhead. That's very important. I think that's really what I made this course with. End of the day, end of this course, I hope you guys can recognize it. And now with all the modules, I hope you can really recognize by just looking at the parts. Okay? The pro and cons you must have knowledge level. Then after compact, for surface wellhead is really the conductor sharing wellhead, which this technology wasn't new as well. A lot of old things for wellhead, but a lot of time it takes ages until people start understand the benefit and understand how to operate it. Then we start adopting it. But again, all these customized more specific, more advanced technology, it associates with your wells construction method, because you need to know what's the difference, how you want to construct a wells with this kind of equipment, which is different to the norm. Okay. Then about manual suspension system, where it's actually another system that hanging the loop and the suspension, the mud line landing. So then we have the subsea wellhead, subsea tree, and BOP pressure testing. So pressure testing, we all know wellhead, pressure containment, they are emphasized quite a bit. So we associate with pressure. So really, one of the most basic formulas we always relate is pressure equals to F over A. Okay, that's will be the last thing that you need to be aware. Okay, so I think course objective is this much lah. Not to rambling through too much. Maybe straight to the point. So what a conductor sharing wellhead is? It started since 1990. So what we do is we all know all the wellhead is sitting on the conductor, and each conductor single wells. We call sometimes also conventional. So that's what you see the nameplate just now. Yesterday the 3D models is written conventional, but that conventional is being used as a compact wellhead as a norm already. It's not the real conventional that each spool hanging each casing string. Okay, So then we talk about having this conductor. A platform has the design for this well slot. One platform is we have the design. So if we are designing couple of well slot, let's say 8 well slot, and we can only complete 8 wells. Even by considering a dual completion, probably we are producing different reservoir zone or whatever, you can double up on it. So then people have introduced this as a conductor sharing system, which is more common we call splitter or triple wellhead. Different manufacturer, different OEM give a different name, just to give a wow factor to everyone. So drilling engineers say, oh, that's the system seems like 2-in-1, 3-in-1, splitter, and the wow factor that they're willing to take the change to improve how we construct the wells and how we can maximize more wells to be completed at the same time. So benefit really maximize the use of the well slots. So for existing well development, well slot availability and potential engineering costs from jackup extension, platform spacing is an equity important driven factor. So by doing this, it allows to drill more wells with minimum number of well slots. We basically double up times 2 or times 3 number of wells on the existing well slot on the same platform. So the disadvantage is there are less casing string will be allowed. Batch drilling required for top hole. That might not applicable for certain design now. We have improved the design also that allows certain wells to complete first, drill and complete one by one, but it's not applicable to all. Then must complete 3 wells together by section, also similar to the batch drilling. This 2 point is actually similar. Like what I said, some system have allowed us to do more to tackle these 2 points. Then restriction on conductor ID and the wellhead landing ring minimum ID. Whenever we associate with a conductor sharing system, this is always a long debate discussion when it comes to some other downhole equipment that we need to drill and need to run. That's all the concern is now. So just imagine drilling a 12.1 bit. Now the minimum ID is 10.5. I cannot drill a 12.1 bit. So what we will do the next? Have you guys covered something like that before? Bit. We can't run the 12.1 bit. What should we do? Under river, we have to open up the hole. Those other tools, right? And those other tools associated with a lot of risk as well. We normally can run a drill bit is the best compared to under river. But under river have its reason why it survived, because it do give some advantage and breakthrough for certain application like this. Okay. So operational benefit not to cover too much because this is really for very sharing purpose for this. We come to this technically this chapter is really at a high level. Then we just need to acknowledge there is such a technology. Okay, so what you can see here is a flow chart. So the flow chart tells, first of all, when we design a splitter or trigger, we need to know what is the conductor size. You design the platform. So by knowing the conductor size, that's where we come down. Is it a 36 inch? Is it a 30 inch, 26 inch, and 26 inch? So if I have a 26 inch, this ID is smaller. So if I have a bigger one, 30 inch, 36 inch, of course I can put more wells on here like that. So what I do is, this from one of the brochure from FMCC, that's how they come down and all this. But this no need to memorize, no need to make it a harsh rules, because technology did improve a little bit from different provider, different OEM. So it might not be truthfully right now. Like 26 inch, the maximum is you can have 2958, but we did some with 33 inch. It's really difficult. No things we have to take it. So that's how the triple well head looks like. So we are completing 3 wells in one same conductor. So what we do is basically, this is 42 inch now. Imagine this is 42 inch, so what they do is really they put 3 wells. So what they do is then the first is a base casing.
But in which case communicate between words, because I think how much distance need to cut between words?
How much distance is this spacing, as long as how to say, as long as there is space you can run, but you need to consider what you run down all up. So there are several things that we use to take care of that. So just really to examples is normally now we do dummy string a lot. So what we do is this is a depth conductor. So we actually run 2 dummy string. Imagine these 2 well slot, we run dummy string to occupy. Then we actually drill this one further. Then after we drill further, we run this casing, we land it. We land this casing. Then we have to pull up this. Then we do the next one. There are several different wells construction methods to do that. So to tackle your concern about spacing, yes, you don't want, because this string is long. So when whatever how big and how rigid it is, when it's long, it's like spaghetti. So if you drill this direction, it might actually go this way. So when you go this way, if this place is not occupied, you don't have the solid things to occupy the space, it might go here. But then you cannot drill this. So that's one of the dummy string as part of the solution. Sometimes they have downhole guide. What they do is in this conductor, they do partition. They do separation. So when you run this casing or drill this casing, this section, you will definitely not go in there. But this can be a very solid plate, like this, whatever board like this, solid plate is a partition. It might be just a guide like centralizers. Those solutions are there. Yeah. But that's how we increase the number of well slots. So imagine this is a real 4 and 3 12 well slot platform. So if we are to drill with a splitter, we are doubling up. The same number of well slots, we can complete 24 wells now. And same thing, if triple, we can complete 36. So this is what physically it looks like. You can see it's sharing the same conductor. This is how it's shown. It's sharing the same conductor. So that's pretty much about such a technology for conductor sharing system. So like what we said, minimum ID critical. So the wellhead here, because of the D-frame or whatever special frame connections, it restricts everything. Because end of the day, the whole thing is geometry. If you don't have space, you don't have space. So when you cannot, let's say this ID, I have 10.6. I can never run a 12 and 1/4, so we have to associate with the run operations. We do need to have a lot of things to take care during the well construction and the operations, because the dummy string, and then you put a dummy string, you run another river. When the other river open here, I introduce to the next one stop. So those are always the things. So we have a lot of best practice. We have done quite a few. The recent years we have done it quite successful, but because ad hoc we have a lot of issue, and even now we saw issue happen. So last year in one of the other operator, they have this issue. So they don't occupy this one. They just leave 20 feet higher. Most likely they having, because of the debt, they cannot run additional full joint 40 feet. So they left about 20 feet here. So when they left about 20 feet here, they drill this one, okay? Somehow it comes to here. And when they drill this, it hit this one. And they have a leaking at this angle come up. So they have an annulus pressure that they cannot tackle, they cannot remove because the wells will be just charging. The pressure you bring down, it will keep charging here. So what happened is then they slim down the whole string from I don't know 5.5, but they eventually bring down to 3.5 or 270. So you got less production. But those are a lot of operation control that we must omit when we plan to conduct pressure wells. Okay. So the restriction is there. Sometimes we also have centralizer. We ever come to centralizer, like the centralizer is a collectible type. So they are very new, just like 10.7. So 10.7, they say when you have a casing weight you run through, it will collapse. And we have to test it. Because we are not going to run it, if you can't prove you can collapse. You don't want to have a lighter casing weight that in the end eventually it doesn't collapse. Then it will stuck there. So there are a lot of these kind of examples that are trying to predict. So we have to be more vigilant on the operation here. Any questions about that? But the benefit is straightforward. That's what you can see really. On the same footprint of the platform we are doubling up. Then we have a magna suspension system. So whenever we drill exploration wells, right? Whenever we drill exploration well, if we are drilling with a checkup rig, so my drawing is going to be very ugly now. So we drill, and this is a seabed. So we're going to have a wellhead at the distance there. Then we run a hole. Then we drill and set a bigger and smaller and all these. Couldn't draw even. So somehow you have a whole casing string. When we do the exploration, then after we completed the wells, we may do logging, we may flow the wells through well tests and all this. Then eventually we have to plug it off because you can't leave a wellhead like that middle in the sea. Right? So eventually we will actually go in, we set all the cement plug, everything, then we will cut the whole things, the whole casing here, remove. So we left whatever, and it's just purely P and N. But if the sand wells I want to enter, I've done my first exploration, which exploration sometimes really depends what we play, and it really depends our appetite on that particular well budget to do the exploration. Sometimes subsurface or whatever owner will say, oh no, I'm not going to floor the wells, just check, just do the wireline coring and all this. So when they do all those, typically you don't have the full data because you don't follow the wells. So with that, then a lot of times appraiser wells come in, I want to drill the same reservoir, but they want to go here, go there, that kind of things. But I can't re-enter, so end up you have to review everything on another location. So So that's where the whole mark line suspension system give you the benefit. So what they do is really, just let's say this is on the seabed. I have my conductor. I have my surface casing. Example 30 inch, 20 inch, and come down to 30 inch. Just for example, I'm not going to sketch through every single string, but just really an example. So this is a mark line suspension system that they have a hanging system below the mark line. So what they do is they are not going to have a wellhead with full pressure containment, but on each string, on this 30 inch, they have a landing ring. So this landing ring will allow to hang 20 inch. No type of, there is no seals, no no isolations between each. And what you do is you rely on your cement as a barrier to isolate the environment. So what I do is if I drill a well with this system during exploration time, then I do temporary suspension. They will put a cap on here. So that's the purpose of mark line suspension system. Suspend the casing weight at or near the mark line to provide pressure control and to provide analyst access. So it's not sealing the access. The reason because when we drill this, we are using this jack-up rig. So I have on this inch. So I have a wellhead here. This box is my wellhead. So when I drill this with surface, I can, like the subsea wellhead we talked about, I can't actually seal it off because I need to allow whatever come out. So I actually using my surface wellhead as an access. So the design is like that. This system is established for this purpose. Okay. So that's what it means. It contained by the whole 30 inch, but each analyst got no sealing pack. So